Hello again, this is Daniel Ritchie, the developer of Howler, and I would like to talk to you about some of the new features that are going into version 9.5. And I'm going to start with the new cloud modeler, or what we call the particle modeler, which is a new feature that has been integrated with the under the animation filter. And I'm going to show you a demonstration of at least one thing that can be done with it, which is sort of a twisting, twirly magic, what you might call a magic cloud tendril, or something to that effect, which is an effect I used to really want to achieve in the old days of working on the show Mystic Knights of Tir na Nog, back in those days, back in the days of The Mummy and The Mummy Returns, and other shows like other TV movies or other movies like that, where you would always see these magic smoke tendrils, and it was something that was popular at the time, and it probably gets used quite a lot even now. But it was something that was difficult to achieve using the technology we had at the time. We did a lot of things with lazy points and lens flares, basically, in Lightwave, but it always stuck with me that we needed to have a feature like this back in the back of my mind. And when it came time to do Howler 9.5, well, we had this little item on our list. And mind you, we have this list, as you might imagine, that goes on for not only for miles, but for years of things to do. Well, it says something like Next Generation Particle System. And at the time, I was also working on the cloud systems for the 3D renderer, the 3D designer, which we wanted to have cloud capabilities in addition to the other new capabilities such as ray tracing and ambient occlusion. And I had to find a way to combine the two ideas, because we just had to move things along. So we thought about it, and by we, I mean me, basically, and came up with this idea of, well, a particle modeler, which would also be a flexible tool for rendering particle-like effects, but not so much where you emit particles from an emitter, but where you start with a particle shape that already exists, or that you model yourself using some basic tools such as an airbrush or something like that. And we came up with what I'm going to show you now, which is what we call the particle modeler. And I'll go to the animated filter and select that right now. And it pretty much duplicates some of the functionality of a full-blown 3D program on some levels, just enough that we were able to get at least particles, or these little points. We have an airbrush tool, we have a sphere that you can add, and you can also make a height map and some other things within it. But I'll just show you adding a sphere. You can, of course, move it around like you would in a 3D program. You can scale it as you would in a 3D program, and rotate it just like you would. Might look a little bit like Lightwave, if you're familiar with Lightwave. Mainly in that it has these 4 views, and the sidebar on the right side. I mean, let's see, the left side here. I've been using Lightwave too many years. I don't know my left from my right anymore. Not quite Lightwave-like, but it's similar enough that you would probably recognize some of the ideas, at least. And we have 2 tabs, one called Model and one called Animate, which you can go to any time when you want to switch between them. And there's some tools on the side, like I said, move, rotate, scale. And there's some parameters that you can also input, such as the size of the blobs that you create, and the density, and all these other parameters. Density is more of an opacity type of setting. You can also apply some basic transformations such as randomize and deform. You can zoom in and out, create a new object, load and save, and create it, instead of creating a complex structure of where you have a bunch of different layers, or different types of objects or something on screen. We decided to make it sort of one step, where you have an object that you can work on, and then there's like a frozen object So you can say, so I added a new sphere here. Well, that sphere I added becomes the new working object, and everything else that we did before becomes sort of a frozen object. So we can work on the part we just added while everything else stays in the background. If we need to, though, we can unfreeze it and work on everything all at once. So that is sort of the work process that we came up with, which was sort of a compromise between doing a more complex layer system. We didn't want it to be where you just worked on one object and everything you did happened to that one object. We wanted to have some discrete level of being able to work on different parts of an object. So that's why that is the way it is. And as I said, we have an airbrush tool. You can draw stuff with it. You can write out letters and all kinds of crazy stuff like that. Once you get done drawing all these points where you want them, just come over here and get ready to render by clicking on that little button there, and that will get your object ready to be rendered. You can then rotate around and view it, sort of a not a perspective view, but sort of a just a view of what it would look like in 3D. You have some control over the brightness and the ambient light and that sort of thing that gets added to it. And there's also a self-shadow parameter, which is sort of a ambient occlusion type of lighting effect. It sort of calculates the internal properties of the light in a way, so that it sort of casts shadows on itself. You also have control over the lighting, which you can click on and then move in different directions, and of course come back to the cloud. There's a few other properties: the shading test distance, the occlusion test distance, and the occlusion samples, which are a little bit complex. Basically, they control the way that the smoothness of the cloud or the blobbiness of the cloud looks. That would really take some experimentation just to get different results, depending on what you want. But the default isn't too bad, and we'll go ahead and use that. And I'm going to go to the animate part of the program. As you see, there's a sort of a visible grid where you can see. It just gives you an idea of where your ground plane might be or something, or just it's there for reference or whatever. And you can click and drag, and that will move your cloud around. You can also click and drag on the lights, and that will move them around. Much like the 3D designer, or rather Puppy Ray, the ray tracer, we have a, in fact it's very similar to Puppy Ray, we have a set of keyframing tools where you can keyframe or set keyframes for motions and scale values, as well as some of the other parameters. So I'll move this back on frame 0. I'll set a keyframe for it, and then I'll move it forward towards the camera on the last keyframe and set a keyframe for that. And you'll see that we can now, oops, flew through the cloud. Let's see, set a keyframe at the end, and now you can see that we can scrub back and forth through that animation that we created by setting those keyframes. And that by itself is kind of dull. We wanted it to look more like a living, blobby, magical tendril type of a thing. You could also do clouds, flying through clouds, for example. With this, you can certainly do that. We have some other parameters that help with that, like this setting we call just alive. Well, all that does is just sort of wobbles each one of these little blobs slightly. So it doesn't. There's not an overall effect of motion, but it just looks like it's scintillating, or just slightly breathing. It's just like it says. It's just alive. Probably more interesting is a secondary motion, which in lightweight parlance would be called lazy points. It basically takes the distance from the center point, or the center point is calculated from the modeler as this cross in the middle. So say we had moved, let me unfreeze this so we can work with that. Say we had moved these particles to there and there. Well, this little spot right here would be the center point. So going back to our let's see, our Let me get that ready to render again. And going back to our animation tab, there it is. Now it shows up. That new center point has become the center. So if we use this secondary motion item, now as we move this around, well, everything that's close to the center point will move almost exactly as we had set the keyframes, while the other parts of the object or the other parts of the cloud will move more slowly and gradually catch up with our motion. So maybe I'll try to go ahead and show an example of that just very quickly. Say we had not only moved this but also scaled it and rotated it. There's some buttons here to do that across the top right. I'm currently on the cloud object, which is what we want to edit. You can also select the lights, the camera, and there's also a secondary light. And then there's a translate, rotate, and scale button. I'll select rotate, and we'll just rotate that object around a little bit, set a keyframe for it. We'll move forward in time a little bit more. I'll rotate it again, but this time I'll also scale it. And set another keyframe. So that should be pretty simple animation. But now, as you see, we click on the secondary motion, and just to demonstrate this better, I'll turn off this this cloud preview, and we'll get just the point, so we can see just what the points look like. It'll run a little bit quicker. There's our. For some reason, I wrote SOS. I'm not sure why, but as we move this around, you can see. Well, what happened there? These areas that were close to our center point are already starting to move, while these all these points further away are not even moving yet. So as you can see there, it gradually starts moving. And there's a laziness factor. I might set that down a little bit so we can just get this to work a little better. There it goes. As you can see, we're getting this sort of dynamic motion, like a cloud waving, or if you had a rag or a towel or something waving in the breeze when you were flying it around in the wind, it would look something like that maybe. So that is just one of the parameters that we've added to this to make it easy to animate. There's also a displacement field, which is sort of a fractal noise which exists within space. And just think of it that we're moving all these points through a turbulent gust of wind. It's going to really blow around and do some interesting things. So that's those are basically the three animation properties we have. Philip has covered this many times, so I don't want to go too far into it. I just wanted to explain some of the reasons why we created the particle modeler. We felt it would be a useful tool, even now, for creating some basic special effects that could be very useful for certain things, for animating certain types of things. For you could for example, you can animate a logo that blows in the wind, that blows away, and the wind causes it to fly off screen or something like that. There's lots of things you could do with it. But it's just one more addition to Howler that we hope you will enjoy experimenting with. Hope you'll enjoy watching some of our tutorials on PD Howler channel on YouTube. And thanks for watching, and talk to you later.